right, welcome back. This is going to be 2.3 notes, the terrestrial planets and moons. So the first thing to talk about is what defines a planet. There are three criteria that have to be met to be able to be considered a planet. One is that it has to orbit a star. Second is that it has to have enough mass for gravity to form it into a nearly round shape, so it has to look like a sphere. And the third thing is that it has to have cleared out the neighboring debris around in its orbit. So in its orbital path, it has to have cleared out most of the different rocks and other bits that would run into. The orbital plane, another thing to talk about, as you can see in the picture down there by my face, is a flat disc-shaped space connecting the center of the object being orbited with the center of orbiting object. So you can see that everything looks like it's flat on one plane and everything is going around the sun in that plane. That's called the orbital plane. And there's one thing that's kind of crisscrossing it funny there, and I believe that is the orbit of Pluto. A terrestrial planet is a rocky planet with a solid surface, often accompanied by few or no moons. Would be like the Earth. A planet is a celestial body that is in orbit around the sun, has nearly round shape, and as we have already pointed out, cleared out most of its orbital neighborhood of debris. So days versus years. Rotation, so when something spins on its axis like the Earth is doing in the top picture, that is a rotation. That is considered a day, an Earth day. A revolution is one object in orbit around another one. So the Earth goes around the sun in 1 year. That would be the Earth revolving around the sun. Okay, so what are the terrestrial planets? The four that we're going to talk about are Mercury, Venus, Earth, and Mars. Pluto used to be considered a planet, but was redesignated as a dwarf planet because it hasn't cleared out its orbit of debris. All right, Mercury. Mercury is the first planet, the closest one to the sun. It is the smallest, and something interesting about it is that it's 1 day on Mercury, so the amount of time it takes to rotate once is 59 Earth days, and its year is 88 Earth days, so it's almost the same as a day. It's the second hottest planet, the side that's facing the sun anyway. There are some craters that have some water ice present in them. There are no moons, it's very heavily cratered, and it has no atmosphere because it's all been cooked away by the sun. The next planet, Venus, like you can see in the picture there, it's very desolate looking on the surface. Venus is the hottest planet in the solar system, and its day is about 243 Earth days. So that is longer than a year, which is 225 Earth days. So its day is actually longer than its year. It takes longer for it to spin around one time than it does to go around the sun. It rotates counterclockwise, so it is an oddball because most of the planets, it's clockwise, most of the planets are counterclockwise. The surface pressure is 90 times the pressure on Earth. That means that if you were standing on the surface, you would be smushed. It is 90 times more or higher pressure. Venus is the second brightest object in our sky, second only to the moon, and the second largest terrestrial planet. It has it has active volcanoes, but no moons. So there are actually volcanoes on the surface that do erupt, but there are no moons around Venus. Okay, the Earth. So, as you may or may not know, about 70% of the surface is covered with liquid water. It's the only planet known to harbor life, as far as we know it anyway. The largest of the terrestrial planets, and we do have one moon, which we just call the moon. It has an atmosphere rich in nitrogen, oxygen, and CO2. It takes us about 365 days, 6 hours, and 9 minutes to go around the sun one time. That's about 365 and a quarter days, which is why every fourth year we have a leap year. The Earth's days are getting slightly longer due to the moon and tidal forces. So the moon is slipping away from us a little bit, and our day is getting a little bit longer. And we are tilted on our axis just over 23 degrees. That's why we have seasons. Our moon is believed to have formed after proto-Earth was struck by a Mars-sized object. So we think there was a collision that happened that caused the moon to form. It used to be between 12 to 19 times closer than it is today. Today it's about 239,000 miles away. It has basically no atmosphere, so it has a lot of temperature variation. The side that faces the sun is much hotter than the side that faces away. We always see the same side of the moon because it rotates at the same speed that it revolves around the planet, so we always see that same side. Its gravity is the source, not the sauce, of the tides on Earth, and the surface is heavily cratered. Mars, this is the red planet, is the second smallest terrestrial planet. It has frozen water ice, and it shows evidence that it used to have running water because it has what looks like different like the like the sorry, the it has different river systems, looks like dried out riverbeds. The tallest mountain is called Olympus Mons. It is about 16 miles tall, and it is the tallest mountain in the solar system. Some fragments from Mars have been found on Earth, so there is some Mars material on our planet. It has a very, very thin atmosphere containing mostly CO2. It has a red color caused by oxidized iron in the surface. That's why we call it the red planet, because it has what looks like rust in the surface rock. And it has two very small moons called Phobos and Deimos. So we'll look at those just a little bit. Phobos is irregularly shaped. It's not big enough to have shaped itself into a sphere. It's about 14 miles in diameter. It's really close. It's the closest orbiting moon in the entire solar system, so it's very close to its own planet. Completes an orbit in about 7 hours and 40 minutes, so that thing is moving fast. It's larger than Deimos, and at some point it will probably run into Mars or break into a thin ring system. Deimos is smaller, irregularly shaped as well. It is not spherical. It orbits every 30.3 hours, and its escape velocity is so low that a human could potentially jump off of it and float away. So your legs would be strong enough to push you right off that moon and you just float into space. It's unknown how it formed. It might have accreted, it might have collided, it might be a captured asteroid. And that is the end of the terrestrial planets.